bit of things. I started doing some natural language processing, but this is not like my actual real background. So the use case for what I was doing is looking at a forum for I guess teens with mental health issues and trying to automatically flag posts on the forum as in need of support or not. So it's like I guess natural language processing is a huge area, and there's many different things that you can do. And one area now that's, I guess, hot is this idea of classifying things because of machine learning. But it requires a lot of this sort of pre-processing of text so that you can transform text into matrices, and then you can do the machine learning bit. So most of today, pretty much all of today, is just some of this sort of pre-processing that you would do on text upstream of the cool machine learning bits or whatever you would do. Yeah, so that's, I guess, my background. Is this recording? Oh, okay.
And if you want to like follow along on your computer, there's instructions in the link on the board, and if something's not working, just let me know.
Yeah. So one thing was like the actual link in the issue does not say book, so you might either want to rename it right off the bat, or just here right at the beginning where it says book.text. It's whatever you saved it as. So yeah, sure. Good. One more. Cool. So first thing first is import NLTK. NLTK is the natural language toolkit. So like I was saying, there's a whole variety of tools and access to texts that you can get out of this. I think historically it was used kind of as a research toolkit. So it's not necessarily like a super well designed in terms of consistent in how it's designed, but there's a lot of stuff in there. And that's what's interesting, I guess, is someone like in the issue, one of the tools that you can sort of download is a Vader sentiment thing. So you can sort of just transform text automatically into some sort of sentiment feature. And that was something that's fairly new, and I thought it was interesting. So you can see that like the package is evolving, and as people say build a tool that's sort of interesting, it seems sometimes they just get incorporated into it. So yeah, it's a constantly evolving package.
So where can we find this?
So I haven't actually uploaded. Well, I put an issue through, but it's I wanted to clean it up. So I guess you guys can type along if you want. I think. Yeah, so first things first, just we'll want to read in the text file. So if you're not familiar with this sort of way of looking at things, you can say like, this is a context manager. Yeah. So when you say like with, open whatever your text file is, and then R to read it as file. So then the file is what we're reading here, and we're passing it to the variable text. So what's cool about doing things in this way is that you don't need to tell your program to close it. It'll automatically close the file once you've done what you needed to do. So you can do that and then sort of take a look, or just whoop. Maybe I have unlock. Yeah, so there's, I think it's like characters. That's 7,000 characters. Sentences. Yeah, so this is a Sherlock Holmes book, and you can see right at the beginning, this is just the first 100 lines. So it's separated by these new line characters, I think that's what you call them. Yeah. So this was just, I wanted to grab a short bit out of the text that we could use. So that's what this snippet is. And I guess there's quite a few things to unpack in here. So one is that if you're not familiar with the slice notation, so this will be taking sentences, or the, roughly sentences from 175 to 200. And then also, are people familiar with this sort of syntax for list comprehensions? Okay, so we could also, I guess this will start in a different way. What you could also say is for block in text 175 to 200. So what we're doing is each chunk, so from like sentence at 175, 176, 177, from 175 to 200, we're naming that sentence block, and then we'll operate on the block. And here, basically what I'm doing is stripping off those new line characters. So block.strip, strip basically just removes white space from both sides, the right and the left of your text. So yeah, so I guess the other thing, this is also join, okay. So this is like string joining. Basically what I'm doing here is you're stripping the white space from each block, and then you're joining those blocks together just with like a single space as opposed to all those new lines. And then what you could do is say, create a new list. I think this is equivalent. If people are familiar with, we could try running that. No. Okay. So first thing we learned here is list comprehensions. So really, because you're going to be doing this a lot with sort of text where you want to operate on your text sequentially, it's kind of nice, instead of constantly writing for loops every time, to sort of write them in a line here and have it be fairly readable. So yeah, that's a good thing to get to know. Anything else here? I think that's good. So I sort of did the same thing with the whole text afterwards, just because I figured it's cool to see how everything can operate quickly. So you can sort of write the same thing afterwards, the whole text, and then just join when you remove out the new line characters. And you can see, for example, what we have here in the text. Okay. Okay, so hopefully we all have text to work with. Let me know if you have any problems. So the first thing, once you have the text that you want to work on, is to think of how you can break it up. So if you take a look at like just the snippet or the whole text like we have right now, it's essentially like a long string. So a long string you could iterate over where each character could be a bit in it, but that's not really how we would want to work with this. You might want to work with larger bits than just the characters. So this is where this idea of tokenizing the whole text is interesting. So I guess the question is, like, what is a token? And a token is whatever meaningful chunk of text there is to you. So if this were like a string of DNA, it could be parts where there's proteins. Maybe you'd want to chunk it into that. But since we're actually talking about natural language, it tends to be sentences and words. Those Those seem to be the most common ways of breaking text up. This gets a lot more complicated if you're working with like social media stuff, where people don't follow standard conventions of how you do this. There's things like emojis, or those could be a token as well. So here what I wrote out was sentences, words, punctuation, numbers, but there's other things which could be tokens as well. And how you think about this would also be important down the line for what's going to show up in how you process your text. So the first sort of tools that are part of NLTK that I think I want to introduce will help us do this. So there's this import statement, if you want to bring these sort of tools into the workspace. So from NLTK.tokenize, there's import sent tokenize and word tokenize. So you can imagine sent tokenize might tokenize things into sentences, whereas word tokenize is supposed to be breaking things up into word-like units. So my first example here, we're going to be working on the snippet, and the example is just like an easy way to think of how you would break text into sentences. So an obvious thing when you go to school and you learn like where does a sentence start and where does it end, tends to be when they're separated by periods. This is obviously not a good enough way to do it because there's different types of punctuation. You can have a question mark or colon or semicolon or all sorts of stuff. But just to sort of show where this can break down, I want to show this function. So if anyone is not super familiar, you can also do like snippet, and then question mark. Oh, I guess do I just do string? Yeah. So this will show you how this function works. So this is part of the standard library for operating on strings, and then you can read the documentation about what's going on here. So you have your string and you're splitting it, and you're saying what separates the string of interest. So return a list of the words in S using the separator as the limit. So basically, I'm going to try and break up our snippet periods.
Yeah.
Yeah.
I missed this.
Okay. Wait, can anyone see is this for loop equivalent to the? No. Yeah. Don't do the for loop. Yeah, so that's not good. What's that? Snippet.append.
And then after the for loop, you do initial image.
Okay. Fancy snippet. Okay. Yeah, so the idea here was just to, I think the idea is that it's simpler to do it in one line once you get familiar with the syntax. Yeah, that's what I'm trying to get across. Okay. Did you get the whole text too? Okay. Okay. Yeah, so I think my snippet's good now. Ah. Okay, cool. So the snippet here is a chunk of text, and we want to split it based off the periods. So you can see like it doesn't snip, or it doesn't, sorry, break things up when there's question marks, or it won't recognize the punctuation that you don't tell it to. One thing that I thought was, the reason I chose this specific snippet was because there's parts that can show you where it's smart. So if you notice the Dr. Mortimer, so it broke the sentence up there because it was Dr. period, and then starts it again with Mortimer. So we're used to these sorts of things where you see like doctor as dr point, but that doesn't mean that you're starting a new sentence. It's just how we, make short forms. So if you've already imported the sent tokenize and word tokenize functions, and you can also test and compare the difference here. So sent tokenize, like I say, has some clever tricks. So you can see here it knows like apply them. I mean, it's clearly much better at doing this. And it didn't mess up on Dr. Mortimer. So it's got some smarts to it. Overall, I would say this is a much better way to just start off and break your text into sentences. Yeah. Okay. And then the alternative was to break things up into words. So this is same thing. You could intuitively, you might say a word is separated by just white space. So that's why I say snippet.split. The default would be to just split everything into words here. So this is interesting, and it mostly works. The point here is also depends, like some things that you might care about could be when I had said like what is a token, and I had included punctuation. So that's like the big difference here. It's also going to be a lot more robust if you use a tool that's made specifically to tokenize things into words. So here you can see like country has a period, and it's included in the whole word token. Whereas if you get your words here with word tokenize, so you're passing to the word tokenize function the snippet text, and then you get the output, which is words, which is a list of tokens. And here you can see that it treats all the punctuation as its own token. So we've got the exclamation mark, period, and all that. So this will also help you count up how many exclamation marks you have. So just as like an easy example of if you want to see if someone's happy in their tweets or whatever, you could just count how many exclamation marks there are. That might be bad because maybe they're really angry, but I mean, there's a lot of information in just those tokens. Yeah, so there's another interesting, what I thought was interesting, quick function to make use of is this NLTK.frequency. So this is a frequency distribution. You can once again use the question mark to see what the documentation. So here, frequency distribution for the outcomes of an experiment. Well, in this case, what you really care about is what's the count of each of these words. Experiments. Yeah, so I mean, they give some examples here. And what we can basically do is pass in, once we've already tokenized things into words, we can pass those words into the frequency distribution. And so I've got a fdist object, a frequency distribution object. And then plot is, well, basically it's so it's a built-in way to visualize the frequency of the words that show up. So I took the 30, once again, if you use the question mark, sort of take a look at what sort of arguments you can pass into the function. This just means I want the top 30 words. And you can see on the x-axis the top 30 words based off of their occurrence. So within that snippet, the word that shows up the most is the, and then a, and then I think it's a period or a comma, in. So you can sort of see the sorts of words which come up the most in the text. So did you guys manage to get a cool plot? So to me, this also sort of starts to tell you something that like maybe we need to add some more processing in here to get more information, because the fact that there's many periods in my entire text doesn't tell me that much, or that the shows up so often. So you want to sort of process this sort of information and remove it so you can be left with the signal as opposed to the noise. So that brings up stop words. So stop words are essentially words that you want to filter out. What I write here is that there is no canonical list of stop words, so we're going to import here from the corpus, which is a bunch of data in that package if you downloaded the right data. So they have a list of stop words and you can see what it is, but it's important to note that, I mean, it's not just like, these aren't the stop words, it's just things that sort of agreed upon that you probably aren't going to get much signal out of. So yeah, all this, yeah. So you can import the stop words from NLTK.corpus and then just create a stops variable and assign it to the stop words. So they're actually didn't play around with it. They probably have other stop words in different languages, but this example is in English. And you can take a look at what the stop words they include are. So I, me, my, myself. These are mostly words that they think, or you might assume may not have too much information. But there's a lot of reasons for why you may not want to remove this or all of these, and you would have to think about what is your specific use case. I just thought because that could be something that actually could be quite valuable. So you can take a look. So this is another one of these examples of a list comprehension. Okay, so this is more practice for the list comprehensions. So in this case, we could try a couple things. So here what I did also is making use of the standard library, so word.lower. So if you take a string and you say .lower, it'll just put it all in lowercase, because I don't want to treat a word that's like capital T tree versus like lowercase tree. It's the same word, it's just whether there's capital or not. So you, in this case, this is the logic behind why I would want to lowercase all the words for comparison. Yeah, so if you just look through this, it's word.lower for word in words if word.lower is not in stops. So it sounds super confusing, right? It's kind of like a tongue twister. But if you work through the logic, so it starts with for word in words. So we're sort of like a for loop, or it is basically. So for each word in our list of words, which were from that snippet that we tokenized, we want to, we'll get below a bit, but we want to check if that word, when it's lowercase, is not in the stop words. So we have a list of stop words. We're checking if it's not in that list. So if it is in that list, we're not going to keep it. If it's not in that list, we'll keep it. If it is in that list, we want to filter it out. And we're keeping the lowercase versions. Okay. So execute, it works pretty quickly. So now you can start to see some of the examples. So I think this is, you can't necessarily see too much just from looking at a list of words. But that's why I thought the frequency distribution is a good sort of plot to quickly see what it is you're actually doing. So we can do the exact same thing. filtered FDist, so this is the filtered frequency distribution, is equal to, basically we're doing the same thing as before, but we're passing the list of filtered words, having removed the stop words out of it. Then you plot the top 30. So it seems a lot more interesting to me, but sort of another thing that I would say is not that interesting is this punctuation. So you can sort of, this is where if you're looking at like how you're going to pre-process this stuff, it's a pipeline of pre-processing your text, and it's trial and error, and you'll see what goes on. You'll want to plot something real quickly and alter the pipeline of how you're processing your text. And so I don't really know, like there's no end goal for what I'm doing here, but to me, I'm not getting much more information from the punctuation, so I'll want to remove it. So this is an example. There's a string library. I think this is part of the standard library, I think. So you can basically check, like string.punctuation basically gives you a string of different types of punctuation. And basically I can just add those to my stop words. So we had the stops, which was equal to just a list of the stop words. And now I can just, instead of this is a one whole string. So here, instead of passing it all in as one long string, I'll treat it as a list. And so it'll break up each element as a separate element of the list and put it all together in the stop words or in stops. So you can say stops. Now, if you want to take a look, you can. You can see it's the same list as before. We've added at the bottom all the punctuation. So now if you do it all over again, this is essentially the same thing as I just did, but with a new updated stop list. And we'll plot the same plot. And so it sort of gives you an idea of, it's not always as easy as you think. You have to keep filtering out different things to get your signal. So these are, I guess, different quotation marks. I'm not entirely sure why there's different ones. So down the line, we can take care of that too. But you can see, at least in that short snippet, words that come up are hospital, country, presentation. You'd probably get more if instead of just working on that short snippet, you would work on the whole text. So we can do that afterwards. So one other idea is, instead of sequentially doing these things all the time, what you can do is build a function which does these sorts of things. So if you have all your raw text, you can think of like the sequence of what you want to do. First, you want to break it up into, well, in this case, I want to break it up into word tokens, and then I want to remove the stop words. And then this was exactly what, basically the last problem. So this filtered words is the same list comprehension as previously. And then now what I've added is another one, slightly shorter, so you can sort of see. So here we have the filtered word here, and we're saying for W, which is word, in filtered words, if the length is greater than 2, then I'll keep it. And that's what keep W, and we put it in the list. So basically, I'm removing those really short things that I didn't like. So now that we have a pool function like that, we can also make use of it and apply it to the whole text. So the whole text, if you just take the first 110 characters, it tells you what the text was. That's the amount of the Baskervilles. You can see len as a function to tell you how long it is. So the name of the function that I have here is process text. So now if I pass the whole text to process text, I'll have my clean text, which doesn't have the stop words or those super short characters. And something to note, if you're all... Yeah.
Can you just go back to the question?
Yeah. So another thing I just want to mention is these sorts of Magic functions, yeah. So with a percent sign, you need to, so if you put 2% signs in the time, it'll just tell you how long it took to process the entire book. So I always find that interesting. I mean, in this case, it took like 1.2 seconds to go through the whole book, check, and do the sort of things that we felt were interesting. So it'll remove the stop words, break it up into tokens, and remove the really short bits too. So going back to the frequency distribution function,